So, the explanation in this video will be based on my worksheet containing my notes, Cambridge past paper questions, and my own solutions with annotated notes to make the workings less unambiguous. So, you can find the worksheet in the description of this video. So, with that being said, let's get cracking with the video. This is the Pioneering Spirit, an absolute behemoth of a ship capable of heavy lifting and decommissioning literal oil rigs. And to be able to displace oil rigs, this juggernaut weighs around 932,000 tons and can weigh around 400,000 gigatons when transporting an oil rig. For context, the USS Nimitz aircraft carrier, one of the largest warships in the world, weighs a mere 100,000 tons. Which now beckons the question, how does the Pioneering Spirit, a ship mostly built out of steel and concrete mind you, manages to keep afloat without sinking? Well, to answer this question, I welcome you to the world of Archimedes' principle. Archimedes of Syracuse was an ancient Greek mathematician and an engineer, also known as the father of the Archimedes principle, which follows the formula of F is equal to rho GV, where F is equal to upthrust, rho density, G the acceleration by gravity, and V the volume of a liquid displaced. Now, I want you to imagine a boat being lowered down into a pond of water. When it enters the pond, it displaces or pushes some of the water downwards. This exerts a pressure on the base of the pond, and according to Newton's third law, an upward force acts on the boat. This upward force, known as upthrust or buoyancy, counters the boat's weight, and when the upthrust matches the boat's weight, then the boat floats. However, if the boat's weight is greater than the upthrust, then the boat sinks, and that is how the Pioneering Spirit floats. Okay, so with that, we move on to the next topic, energy. Whilst the rest of the chapter deals with topics that you've learned at O-level, such as work done and force. For your A-levels, we will need to study the energy equation relationships. But first, there are two forms of energy that you will be studying in this topic, notably number 1, kinetic energy, and number 2, potential energy. Kinetic energy is defined as the energy an object possesses due to its motion. Given it a formula of Ek is equal to half mv squared, whilst potential energy is defined as the energy an object possesses due to its position or height, given it a formula of Ep is equal to mgh. But most important in this topic is the energy relation equations, which follows that loss in an energy is equal to a gain in another energy. So for example, loss in potential energy is equal to gain in kinetic energy, and vice versa. To visualize this, meet Sam, who's on a roller coaster. He's having a good time. When he's at the top of the track, his potential energy is high, whilst kinetic energy is low. And as he descends down the track, his potential energy gradually decreases, whilst his kinetic energy gradually increases. Ad infinitum. Well, not really. I mean, he kind of got yeeted into the water eventually, but if he didn't, this relationship would have persisted. You get the point. Right, so imagine the track had friction. We would then get the following equations. Loss in potential energy is equal to gain in kinetic energy, plus the work done by resistance, or the loss in kinetic energy is equal to the gain in potential energy, plus the work done against resistance. Now, you can also calculate the work done by resistance by using the formula work done is equal to force times distance. Whilst force can be calculated using force is equal to mass times acceleration, or force minus resistance is equal to mass times acceleration. Now for the rest of this topic, there is only two equations you need to know, that of power and efficiency. Usually, when we build a machine or a robot, we need to find out how efficient is the machine, and we do this by calculating the ratio of output and input power. Speaking of which, power is given by the formula of power is equal to work done over time taken, or power is equal to velocity times force. That's your first equation. The second equation being efficiency, which is
efficiency is equal to output power over input power times 100%. This gives us an idea of how much power has been lost to waste. So with that, let's crack on some past paper questions. So we are going to be working some past paper questions now. So for the first question then, we have a sphere that's floating at equilibrium on surface of seawater with a density of 10,050 as shown in the diagram. Okay, so let's see what information we can extract here. We got 21% of the volume of the sphere is below the surface of the water. So 21% can also be written as 21 over 100. That would give us 0.21. This is now a fraction which we will be using. This is an Archimedes principle question. So we have our upthrust and we have our weight. So let's start by writing the equation for upthrust. I'm going to denote upthrust by Fu for sake of simplicity. So we got Fu is equal to rho g v. Okay, so we are to calculate the density of the sphere. Right, the density of seawater is 1050. So 1050 times the acceleration by gravity, which is 9.81 times the volume displaced by the sphere. The problem here is that they did not specifically give us the volume displaced by the sphere, but they did tell us that 21% of the volume of the sphere is below the surface of water. So we are going to be using the volume of the sphere as a point of reference. I want you to imagine the entirety of the volume of the sphere is equal to V. Now, this part right here is the only part of the sphere that's below the surface of water, which is 0.21. Therefore, this would be 0.21 of V. So our volume will be 0.21 V. Now we are going to write the formula for weight, which is W is equal to mg. That was a terrible G. mg. But the problem here is that they did not give us the density of the sphere. We are to calculate the density of the sphere. Neither did they give us the volume, so we can't find the mass of the sphere. But so this equation can't be used. But we know that the sphere is floating. We also know, in order for the sphere to float, the upthrust must equal to the weight of the sphere. So, because they are equal, we can write the weight of the sphere using this formula. Weight is equal to rho,
being the density of the sphere which we are to find,
GV. Rho times
9.81
times V. V because it's the volume of the sphere. Great. So now to calculate the density of the sphere, we simply need to equate both of the equations. So upthrust, Fu, is equal to the weight, to the weight, W. So we have upthrust, which is 1050 times 9.81 times 0.21 V is equal to rho times 9.81 times V. We can now eliminate 9.81 and V, which means we are now left only with 1050 times 0.21 is equal to rho. Therefore, rho is equal to 1050 times 0.21 is equal to 220.5. Rho is therefore 220. Density is therefore 220. Moving on to the next question. We are to calculate the initial acceleration of the sphere. And we're going to do this by using the formula of force, which is F is equal to mass times acceleration. But here's the thing, the force, the upward force, is in fact the upthrust. And we have a resistance to this force, which is our weight. I want you to remember that the ball is moving upwards because of the upthrust, but the weight is also acting vertically downwards. So we need to account for the weight in our equation. So force, which is also the upthrust, so I'm just going to write Fu, minus weight is equal to mass times acceleration. I'm going to get rid of this diagram here to make some space. We need to calculate the acceleration. So acceleration is equal to Fu minus weight over mass. Now, we have the density of the sphere, which we calculated over here. Meaning, we can now calculate the mass of the sphere. We also know that density is equal to mass over volume. Mass is equal to density times volume. We don't know the volume, but that doesn't matter. Therefore, mass is equal to 220 times V. Now, we need to plug in everything into our equation. We know that mass is equal to 220 V, whilst our upthrust is given by this formula right here, and our weight is over here. Those are terrible lines. I'm truly sorry for not doing the lines properly, but please forgive me. My pen is actually not in my favor today. Okay, so we are simply going to write both of these equations down here. Upthrust is going to be 1050 times 9.81 times 0.21 V minus the weight, which is our density, which we calculated, 220 times 9.81 times v. We can now cancel all the v's, so v, v, v. And that gives us 1050 times 9.81 times 0.21 minus 220 times 9.81 over 220, which is going to give us an acceleration of 37. And that's your answer. Moving on to the next question. The sphere accelerates upwards but remains entirely below the surface of water. State and explain what happens to the acceleration of the sphere as its velocity begins to increase. So we have our surface of water here, we have a sphere, and we have our upward force, which is the upthrust, and we have a downward force, which is the weight, and we also have drag, which is caused by the liquid. It's the viscous force which is acting downwards, it's opposing the upward force. The net force, F net, is equal to upthrust minus weight plus the drag force. Okay, we also know that the net force is equal to mass times acceleration. But first, we need to break down both of these into their components, so W and D. W is the weight, which is mg, is going to remain constant because weight isn't increasing. You're not increasing the mass of the sphere. It's remaining constant, so this is a constant. But what about drag? Well, drag is the only factor in here that's going to change. So drag is going to increase as the velocity increases. So as our drag force increases, our net force decreases because upthrust remains constant. I'm just going to write constant like this. Constant. Upthrust and weight remain constant, but drag increases. So if we had 20 minus 10, that would give us 10. But if we were to increase this by, say, 19, we would get 1. This is what's happening here. Drag force is increasing and it's subtracting from the upthrust. Therefore, our F net is going to decrease. Our F net is going to decrease because of this. F net is going to decrease and acceleration is also going to decrease because F is directly proportional to A. But, so F is going to decrease, A is going to decrease, but V is increasing. So we can conclude that when V increases, acceleration decreases. Therefore, our answer is going to be, because the downward viscous force increases, the resultant force decreases with upthrust and weight remaining the same or constant. Therefore, acceleration decreases. Right, so moving on to the next question then. A sphere, a spherical balloon, is filled with a mixed mass of gas. A small block is connected by the string to the balloon as shown in figure 2.1. The block is held to the ground by an external force. The upthrust acting on the ball is 0.071 newtons. The upthrust acting on the string and the block is negligible. By using Archimedes' principle, calculate the radius of the balloon. So first thing that comes to mind is the volume. We will need to pass through volume. So what's the volume of a sphere? Well, that is V is equal to 4 over 3 pi r cube. Terrible cube over there. Cube there. Now, Archimedes principle, we simply need to write our formula for upthrust, which is F is equal to rho g v. We already have the formula for V over here, and we have to calculate the radius. So let's just substitute that in. F is equal to rho g times 4 over 3 pi r cube. Now we are now going to be making r the subject of formula. So r cube is equal to F times 3 over rho g times pi. Okay, what the hell is that? Times pi times 4. R is equal to the cube root. So F3 over rho g pi 4. This is way too short for cube root there. Actually, I think I might just do it right here. So we have our cube root. Now we have our upthrust, which is 0.071. So 0.071 times 3 over our density, which is 1.2, times G, which is 9.81, times pi times 4. And that is going to give us 0.11. So 0.11, that's your answer. Moving on to the next question. Calculate the acceleration of the block immediately after it is released. So, right, acceleration. Whenever you see acceleration, just know you need to use this formula right here. Force is equal to ma. Well, not always. If you're dealing with a question based on kinematics, then you'll need to use your formula, kinematics formula. But when we're dealing with force, it's always F is equal to ma. The total weight of the balloon, string and block is this much. That is what's going to be your resistance. So we have our upthrust, which is acting right here, and the balloon, the string, and the block have a weight of 0.053, and that's your resistance, the combined resistance. So F minus R is equal to ma. A is equal to F minus R over M. But we also need to calculate the mass of the total of the string, the balloon, and the block. So we have the weight. Weight is equal to mg. Mass is equal to weight over g. Is equal to 0.053 over 9.81, which is going to give us 5.40 times 10 raised to the power of negative 3. So our upthrust is 0.071 minus our resistance, which is 0.053, and our mass, which is 5.40 times 10 raised to the power of negative 3. That is going to give us an answer of 3.3, a very humble answer. 3.3, that's it, done. moving on to the third question. Okay, so define power. Power is defined as the work done per unit time. Keep in mind that power has a formula of P is equal to work done over time taken. It's in the worksheet I provided, so please go through that before you start working the past paper questions. It's going to be very helpful, trust me. Right, so the mechanical power P can be calculated using the formula of P is equal to FV. Yes, this is also another formula that you're going to be using. There are two formulas for power. Well, actually, there are more that you'll be studying in electricity, but for now, it's just work done over time taken, or power is equal to force times velocity. Use the concept of work and the definition of power to show how this formula is derived. Seems like I'm going to be using this formula right here. Power is equal to work done over time taken. Work done is equal to force times distance. So power is equal, we are going to be substituting work done with this. So force times distance over time taken. Power is equal to force. We remove the force outwards. Distance over time taken. We know that velocity is equal to distance over time. Therefore, we can substitute this by V. Power is equal to F times, it's actually V. I don't know why I'm being so sloppy today. Therefore, shown, looks like I'm freezing snow, but whatever. Right, so the engine of the lorry provides 130 kilowatts of power to the lorry's wheels when it's traveling at a constant speed of 25 meters per second. Show that the resistive force opposing the forward motion of the lorry is this much. Using P is equal to F times V, we can calculate force, because this is in newtons, it's a force. Power is in watts. So force is equal to power over V is equal to 130 times 10 raised to the power of 3 over the velocity, which is 25. That gives us 5,200. Yeah. Yep. Right. So that's our force, our forward force. We also know that F is equal to ma. Force minus the resistance is equal to ma. But the formula of acceleration is equal to delta V over t. Here it says constant speed. Therefore, there is no change in speed. It's constant. So it's not like acceleration is equal to V minus U over t. It's just V. It's constant speed. So constant speed means acceleration is 0. Therefore, F minus R is equal to 0. F is equal to R, from which we can deduce that R is equal to 5,200 newtons, which is the same as the forward force. But moving on. Right, so the lorry has mass m and acceleration, and the acceleration of free fall is g, blah blah blah. Determine an expression in terms of m, g, and theta for the component of the weight of the lorry that acts parallel to the surface of the road. So we need to resolve perpendicular to the elevation, perpendicular 90 degrees here, we are going to get mg cos theta and, okay, so this is going to be mg sine theta plus resistance. Now, the question wants us to know the weight that acts parallel to the surface of the road. Parallel, that's going to be this line right here, because it's parallel. That is going to be mg sine theta, not plus r, that's completely separate. Moving on to the last part of the question. Determine the power in kilowatts provided by the engine. The total resistive force remains unchanged at 5,200 newtons, and the engine now provides a greater power to maintain the speed of 25 meters per second. The total mass M of the lorry is 36,000 kilograms. The angle theta is 1.4 degrees. Okay, so this right here is going to be our driving force, because it's moving forward, driving force. Our driving force is going to be equal to these two right here. So driving force is equal to the backward force. So total resistive force, driving force dF, I'm just going to write it as dF for short form, is equal to the resistance, which is this right here. So 5,200 plus mg sine theta. Okay, so our driving force is going to be 5,200 plus 36,000 times 9.81 times sine 1.4 is equal to 5,200 plus 8,600 is equal to 13,800 newtons. But we need to provide the answer in kilowatts. So power is equal to force times V is equal to 13,800 times 25. That's going to give us 34,507.11. That's such a huge number. That's going to round off to 2, 3, 4 zeros, which is going to give us 350 kilowatts. So 350 kilowatts. That's your answer. Moving on to the fourth and last question. Work done is the product of force times distance in the direction of the force. Show that the mass of the ball is 0.18 kilograms. So we are going to write our information. EP is equal to 60 and EK is equal to 23 joules. EK is equal to half mv square. We know our kinetic energy is 23 is equal to half times mass times the velocity, which is 16 to the square. Mass is going to be 23 times 2 over 16 to the square. Therefore, our mass is going to be 0.18 kg. There. Calculate the height of the balcony above the ground. EP is equal to mgh. H is equal to EP over mg is equal to EP, which was, I think 60, 60. 60 over the mass of the ball, which is 0.18, times 9.81, which is going to give us 34. Therefore, our height is going to be 34 meters. 34 meters. Awesome. Determine the average resistive force acting on the ball as it falls from the balcony to the ground. This is where we're going to be using the energy equation relationships. Determine the average resistive force acting on the ball as it falls from the balcony to the ground. Let's say the ball is falling to the ground. There is a loss in EP, and when it hits the ground, there is a gain in EK. So, loss in EP is equal to gain in EK plus work done by R. Work done by R is equal to loss in EP minus the gain in EK. That is going to be 60 minus 23 is equal to 37 joules. So we know that work done is equal to force times distance. Force is equal to work done over distance. Work done is going to be 37 over the height, which we calculated right here, which is 34, is equal to 1.1 newtons. 1.1 newtons. That's such a lovely number. 1.1. Right, so state one of these stating questions again. State and explain the variation. State and explain the variation, if any, in the magnitude of the acceleration of the ball in B during the time interval when the ball is moving downwards before it reaches the constant terminal velocity. Right, so what's happening over here? We have F minus R is equal to ma. Force is equal to ma. We know that force is directly proportional to acceleration. Therefore, when R increases, F decreases. When F decreases, because F is proportional to acceleration, then acceleration also decreases, as F is directly proportional to A. Therefore, your answer is going to be air resistance acting on the ball increases, therefore the resultant force acting on the ball decreases, hence acceleration decreases. And with that, we complete the topics of Archimedes' principle and force and work done. Okay, so before I end this video, I just wanted to say it's okay if you're struggling with your A-levels, with studying. Look, you are in a stage where you are going to be attacked by imposter syndrome, and it's going to nag at you, it's going to tell you that you're not enough, you're not good enough, you can't do this. But please, never lose hope. Never lose hope. You can do this. Keep fighting. You will make it. I know it's very hard, and it's easy to be overwhelmed by all of this, especially if you have exams and assignments one under the other. But at the end of the day, I want you to know that you're smart. You can do this. I want you to meditate. I want you every morning for at least 10 minutes just to sit down, breathe in, breathe out, and tell yourself, you're good enough, you can do this. I don't know how I went on a tangent here, but I don't know, I might delete this or keep in the video, I'm not sure. But yeah, thank you for watching my video, and I hope the worksheets and everything is quite helpful, and good luck. Again, thank you for watching my video. Bye bye.